Hey gang, I didn't hit the record button, sorry. I'm gonna have to take it from the start. So the first thing is, and this is from pre-calc, I can't go, it just takes too long for me to go over it, but if you remember, you'll have to watch the video. I think I posted it in 3.6. If you remember, we cut the sine function to make it 1-to-1, so therefore it had an inverse. So the domain and the range swap, so the domain of the arc sine is -1-to-1. It's not all real numbers, okay? It's this, and I was taking the derivative of this. The derivative is 4 times whatever you get, so the derivative of x is 1, and for the arc sine, I put the formula up here. The u value is x, so the derivative of x is 1, and then 1 minus your x value is the 1 minus the x squared. So this was the derivative using your formula. Alright, so the derivative is equal to 0, right? We'll find the critical numbers. What's the easiest way for you guys to do this? I'm going to just divide off the 4 now since this is equal to 0, so you really just have this. I'm just trying to think of the easiest way for you guys to do this. We could just maybe move it that way. Then we can cross multiply this. Then we can square both sides. I'm going to bring the x squared to the right, the 1 to the left. Okay. So when you do all the algebra, you're going to get here that the critical number is 0. Now, just notice that this is not, undefined isn't going to work, because if it's undefined, it has a value of positive or -1, and that's the endpoints of the interval. So remember, when you do the critical number, it's when the derivative equal to 0 or when the derivative is undefined. And what I'm trying to say here is undefined does not apply because undefined is happening at the end points of the domain. Right? It's happening at the end points of the domain. Alright, so we have one critical number. Hopefully you guys are good with the algebra. Lots of algebra and calculus. Alright, so notice when I write the derivative and I look at the derivative, we have to stay within -1 and 1 because that's the domain. You cannot test the function where it doesn't exist or doesn't live. There is no graph outside of -1 and 1. So you have to take that into account. You can't test something that doesn't exist. And then you've got your critical number here at x is equal to 0 that we solved for. So now I'm going to test the derivative to the right and the left of this value. So, you know, something nice might be like -1/2 and like maybe +1/2. It just depends what you like. You want to know whether the derivative is positive or negative. So f prime of -1/2, you're going to plug that in for 1 minus 1 over 1 minus -1/2 squared. So 4 times 1 minus. For the people that this is obvious, you don't need me doing this, but I think because it's so funky, I'm just sort of writing out some steps for you. -1/2 squared is 1/4. Okay, so 4 times 1 minus 1 over, this is going to end up being 3/4, and then 4, 1 minus, I sort of want to like, I want to pull out the 4, take the square root and flip it up, but I'm afraid I'm going to get really confusing. That's going to confuse people if I keep going with the algebra, so maybe let me just go ahead and wrap it up. So you can see that you can just test it. So you're going to do 1 minus 1 divided by square. You don't have to worry about the 4. You just want to this is positive, so positive times whatever the sign of this is. Okay, so you're going to get negative 0.15, and again, that is going to be multiplied by 4, but what matters is that this is going to end up being negative, so that this means this is negative. The graph is going down here. Now, if you notice, because this is squared, if you put in positive 1/2, it's going to give you the same exact value. Positive 1/2 will give you 1/4. You're going to get the same result here. Okay, so that means that whatever the graph is doing, it's going down, then you hit the critical number, and then it's going down again. Okay, so it's like going down. It just keeps going down. So in terms of the way they want this written, we did part A here. That was your critical number. And we did part, what else did they want? Oh, we're doing part B now. We're testing for part B. Okay, so for part B, the function is decreasing from negative, sorry, not negative infinity. You have to watch what you write. Negative 1 to 1. Okay, because the function is going down. So it's going down from negative 1 to 1. Sometimes your book doesn't like to include the 0. Sometimes your book doesn't like to include the 0. Sorry, I feel like a pile of pens over here. Sometimes it doesn't like to include the 0. So sometimes you'll see it written like this. And I just sort of like let it go, which either way the student writes it, as long as you know that it's coming down. And the reason it'll sometimes write it like this is the derivative being equal to 0 versus being a negative. It's sort of like a different value. But if you write it like this or write it like this, you chop off the critical number and just say that it's decreasing. I'm going to take it. Alright, so I'm going to leave it like this because I think for most people they sort of prefer that. And what's the last part? Oh, this has no relative extrema. Right, because as we just said, it goes down and then it goes down. So it's not going to make a max or a min. Alright, gang, that's it on this one. I'll catch you. Bye-bye. So this is no for this one. If I wasn't clear, there's none. Okay, catch you. Bye.